All right, so on this lesson, we are going to do a warm-up first, but then after that, I'm using an old lesson from MVP, which is Mathematics Vision Project. It has now changed to Open Up. It is resources that the state uses, and I used to use them at one of my old schools, and I absolutely love this lesson, so I thought it would be a great one for us to use because it has lots of word problems in it. All right, so I want you to take just a minute and I want you to pause this video and I want you to do the warm up. All right, hopefully you're finished by now. Here are my answers to the warm up. So on number one, I distributed first, then I combined like terms, moved my variable to the left because I like it on the left when I'm doing inequalities, and then moved my constants to the right, and then solved for my variable. Remember that when you divide by a negative, you have to flip your fraction. And then you can see that I drew my number line with a open circle because it did not have the equal to, and the arrow was pointing to the right because my variable is on the left, but my inequality symbol is pointing to the right. Okay, remember that you can plug it back into Desmos and see if it makes a true statement. So 4 times 2 um, is 8. 1 minus 8 is -7, and 2 times -7 is -14. All right, 2 plus 3 is 6 times -2 is -12 minus, sorry, 2 times 3 is 5 times -2 is -10 minus 4 is -14. Okay, so that works out in terms of the number, and then you can check your arrow as well. Apologies for that. I'm a little tired. All right, pause it if you need to. I'm going to keep moving. You can look through number 2 as well and see all the steps and the answer there. All right, so again, this is an old MVP lesson. They are really good because they have lots of word problems. So this is actually a solidifying understanding task, which means that I would have taught just how to um, solve inequalities the day before, but then we would do word problems the next day to see if you guys understood how to do it. So for this first problem, it says Elvira, the cafeteria manager, has to be careful with her spending and manages the cafeteria so that they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analyzes all of her budgets. Elvira's cafeteria has those cute little cartons of milk that are typical of school lunch. The milk supplier charges 35 cents per carton of milk in addition to a delivery charge of $75. What is the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk? Write and solve an inequality that models this situation. Now, first thing that you need to do is you need to determine what your variable is going to represent. So if you look at this, you have to determine what is going to make the amount higher. Is it going to be the 35 cents per carton, or is it going to be the flat fee of the $75 delivery charge? Well, the per carton, the more you buy, the more expensive your bill is going to be. So X is going to represent number of cartons of milk. Okay. Now, the next thing that we're going to do is we're going to write our inequality. Remember that you write it just like you would an equation, except for it has an inequality symbol instead of an equals. So we know that our 0.35 is going to be multiplied by X because we don't know how many cartons of milk she's going to buy. We just know that they're 35 cents a piece. And we know that she's going to pay a flat fee of $75. Okay. Now, we know that it says she is trying to find out the maximum number of cartons she can buy if she has budgeted $500. Okay, so $500 is going to go right here, but we're not exactly sure what our inequality is yet. So it says that she has budgeted $500. Now, I want you to think about if your parents give you an allowance to spend on clothes or shoes and you go shopping, okay, and let's say that you have $500 and you start considering how much each of your outfits cost and you're calculating it in your head and you think, oh, this is exactly $500, but then you forget you have tax. Okay, so you actually would go over the $500. All right, so what you need to think is when you have a budget, you cannot spend more than that. Okay, so no more than that means that you're going to do less than or equal to. You can spend less than $500 and you stay within your budget, or you can spend exactly $500 and stay within your budget. But you cannot go over. If you do greater than, that means you're going over $500. All right, I hope that's making sense. So I'm going to keep moving. Next thing I'm going to do is I'm going to solve it just like I did inequalities yesterday. So we're going to subtract the $75 and we're left with 0.35x on the left is less than or equal to 400 and, oh, I started right the wrong thing there, $425. All right. Now, next thing that you want to do is you want to divide both sides by the 35 cents to see how many you can get. And what you're going to end up with is actually a decimal. So x is less than or equal to 1,214. And I'm just going to put point, I'm going to round it to 3. Okay. But I'm going to stop there. The decimal is actually 1,214.28571, and it'd probably keep going. But remember that 8 rounds the 2 up to a 3. Now, I want you to think about the context of the problem, okay? I want you to think about the context of the problem because it says describe in words the quantities that would work in this situation. Well, she could just decide that she really doesn't need to buy any, right? So we could say Elvira could choose to purchase between 0 and 1,214 cartons of milk. Now, you'll notice that this time I did not put the decimal. You cannot purchase a portion of a carton of milk, okay? So I cut it off at the decimal. Now, let's say that my decimal ends up being 0.8. You still cannot round up to 1,214 because, sorry, 1,215 because if you do, you're going to go over budget. All right, so that's how you can always check to see what you can actually do. All right, now down here on part C, it says write your answer using appropriate notation. That is something that you guys have not learned yet, so you can just mark through part C for right now. Later on, when we start doing interval notation and inequality notation, you will learn that. But for this lesson, you don't know how to do that yet. All right? So pause it if you need to. I'm going to keep going here in just a second. Also, don't forget to put stars by anything that you are totally lost on, especially which color step you're stuck on. That way, when I pull the notes back up to go over something with you, I'll know where you got stuck at. All right. Also, remember that I may make a mistake as I go along, so you're welcome to point that out as well. All right. Pause it. I'm going to keep going. Okay. Next, students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat about 2.25 gallons of ranch each day. She started the school year with 130 gallons of ranch dressing, and she needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. For how many days will her ranch dressing supply last before she needs to reorder? All right. Again, we got to write and solve an inequality that models this situation. All right. So we are going to let X represent number of days. All right. Because it says that the students eat 2.25 gallons of ranch each day. All right. There's our X. Now that we see that, we know what goes with our X is 2.25x. All right. She already had 130 gallons of ranch dressing at the beginning. So she started with that. So she was in the positive 130 already. And then it says she needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. So we know 20 is going to go over here. And now we got to figure out our inequality. Okay. If she has less than 20 gallons, then she's not going to have any in stock when she needs it before her order comes. Okay. So the words at least means greater than or equal to. Again, let's think about going shopping for those clothes. If we need at least 20 bucks for underwear and socks, but mom and dad only gives us 10, we don't have enough. Okay. But if they give us 50, then we've got greater than the amount that we need. Okay. If we get 20, we have exactly what we need. All right. So hopefully that's making sense. Let's keep going. We're going to subtract 130. All right, and we get 2.25x is greater than or equal to negative 110. And I just realized what I forgot up here. All right, it says that they're eating 2.25, so that should be negative. Apologies there. Totally forgot that. So negative. All right, I bet some of you already caught that, and you're giggling to yourself. I would be too if I were you. All right, next we're going to divide the negative 2.25. So 110 divided by 2.25. All right, and so again, I'm going to get x is less than or equal to 48 point, I'm going to round it to 9 because it's 48.8 repeating. Okay, and it says for how many days will her ranch dressing supply last before she needs to reorder? So this says x has to be less than or equal to 48.9. Now, here we can check and see if we do negative 2.25 times, I get my calculator to work, 48 plus 130, we get 22 is greater than or equal to 20. Okay, so 48 definitely works. Let's see if we round it up, what will happen. So again, negative 2.25 times 49 plus 130 equals 19.75. So again, this is why we don't round up when we're doing the word problems for inequalities, because it will not work. Okay? It makes it not a true statement. So we got to be careful there. All right? So again, describe in words the quantities that would work in this situation. Elvira could order ranch dressing between day 0 and day 48. All right, and that is so that she can make sure that she has enough in stock until her next order comes in. All right. I know most of you are probably wondering what that means, day 0. That just means her initial value, um, which could mean that she orders it before school even starts, like before the kids even come back. She's ordered the ranch dressing. Day 1 would be like the first day of school. Day 2 would be the second day of school, and so on. All right. Again, down here at the bottom, you do not have to do that part, so you can mark through that. Pause it if you need to. I'm going to keep going. All right. The prices on many of the cafeteria foods change during the year. Elvira finds that she has ordered veggie burgers 4 times and paid $78, $72, $87, and $90 on the orders. To stay within our budget, Elvira needs to be sure that the average order of veggie burgers is not more than $82. How much can she spend on the 5th order to keep the average order within her budget? Now, notice that it uses the word average right here. All right. Average is when you add up numbers and then you divide by how many numbers you have, right? You guys have learned that before already. So we know, sorry, X is going to represent the 5th order. Forgot to write that down for you. We know that she has ordered 4 times already. So $78 plus $72 plus $87 plus $90 plus we don't know the 5th one, so we're going to call it X. And to find average, you have to divide by 5. Now, she wants her average to be not more than $82. So 82 is going over here, right? Now, again, if you can't spend more than that, then it is less than or equal to. So not more than, a lot of people get confused because it has that word more and they think greater. But not more negates that, meaning it flips it around. Okay? All right, we're going to solve this. So what I'm going to do is I'm going to multiply both sides by 5. But at the same time, I'm going to go ahead and add my numbers in the numerator. Excuse me, 78 plus 72 plus 87 plus 90 gives me 327 plus x is less than or equal to. 82 times 5 is $410. Okay, our 5's canceled over here on the left because I have one on the top and one on the bottom. Now I'm going to subtract that 327 so that I can get x by itself, and we get x is less than or equal to $83. All right. So describe in words the quantities that would work here. Elvira, well, sorry about that. Could spend between 0 and $83 on the 5th order of veggie burgers. And she would stay in budget, right? All right, again at the bottom, mark that out. We're not worried about number line here. I will tell you though, now that I've brought the number line up, for this number line, it would look like this right here. This would be 0, this would be 83, okay, and you would have a closed circle here, and here, and your line would be in between it. You couldn't go less than that because you can't buy negative veggie burgers, and you can't buy more than, sorry, you can't spend more than $83. So you can't spend negative money because you don't have negative money, and you can't spend more than 83. All right. Pause it if you need to. I'm going to keep going. All right. She purchases ready-made pizzas for $14.50 each. If she makes them in the cafeteria, she can spend $44.20 on ingredients and $6.25 per pizza on labor. For how many pizzas is it cheaper for the cafeteria to make the pizzas themselves rather than buy ready-made? All right, so X is going to represent pizzas. All right, so for ready-made pizzas, it's $14.50 each. So 14.50x. All right, and then I'm going to move this over here. You'll see why in a second. To make them in the cafeteria, she can spend $44.20 on ingredients. So that's a set fee. And $6.25 per pizza for labor. So plus 6.25x. All right, for how many pizzas is it cheaper for the cafeteria to make the pizzas themselves? So you want this to be less than the $14.50 per ready-made pizzas. Okay? Less than is cheaper. It doesn't say less than or equal to, it says less than, okay, or cheaper. So we're going to subtract the 6.25x, and I get 44.20 is less, let me get my calculator back out, 14.5 minus 6.25 is 8.25x divide by 8.25. And we get 5 point, I'm going to round it to 4, is less than x. All right. Now, again, you can't really round up. So x has to be greater than 5, meaning 5.4. Okay, so on this one, let's look. If I do 44.2 times, let's round up this, sorry about that, 44.2 plus 6.25 times, I'm going to round up to 6 just for the heck of it. That's 8170. And if I do 14.5 times 6, that's $87. Okay? So 6 is greater than 5.4, right? You have to have more than 5 pizzas because 5.4 is less than 6. So you got to have 6 or greater, okay? Because this one does not have the equal to. So you can word it different ways, but I'm going to word it this way. Elvira must make more than 5, and then I'm going to put in a comma. So at least 6 pizzas to be cheaper than ready-made. Now, if you think about how many pizzas they make in the cafeteria, she's definitely going to be fine because they definitely make more than 5 pizzas, okay, to feed kids pizza. All right. Again, mark out part C. Pause it if you need to. I'm going to keep moving. All right, so now she's comparing prices between two different suppliers of fresh veggies. She's got Val's Veggies that charges $250 for delivery plus $1.50 per bag of lettuce, and Sally's Salads charges $100 for delivery plus $4 per bag of lettuce. How many bags of lettuce must be purchased for Val's Veggies to be the cheaper option? Okay, so X is going to be bags of lettuce. All right. And so what we're going to do is we want Val's Veggies to be cheaper. So I'm going to write it in words first. Val's needs to be less than Sally's. All right. Now let's figure out our equation. All right. It says Val's Veggies charges $2.50 for delivery plus $1.50 per bag. So 2.50 X plus the 250 for delivery. All right, needs to be less than Sally's, which charges $100 for delivery, plus $4 per bag. All right. So I'm going to subtract my 4x or $4x. And since I write so fat, I'm going to move this around a little bit so that I got room. All right. So I got negative 1.5x plus $250 is less than $100. All right, now let's get our money on the same side. Subtract 250. And we get negative 1.5x is less than negative 150. And then divide by that negative 1.5. Remember that when we divide, we have to flip our signs. So we get x is greater than 100 bags of lettuce. All right. So describe in words the quantities that would work in this situation. Elvira must purchase more than 100. So I'm going to put in parentheses at least 101 bags of lettuce for Val's to be cheaper than Sally's. All right. And again, mark out part C. Pause it if you need to. I'm going to keep moving. All right, each student that buys lunch pays $2.75. The cafeteria typically brings in between these two different amounts of money. How many students does the cafeteria usually serve? Now, this one is a weird problem, okay, since it tells you that it's between two different amounts, okay, and it's $2.75 per student. X is going to represent student. All right, for this one, it's between, so you've got 1,168.75 is less than or equal to 2.75x is less than or equal to 14,000, sorry, $1,438.25. All right, because it's between those two dollar amounts, and you know that you're paying $2.75 per student. So what we're going to do is divide every piece by 275. And you get, 1 second, let me pull my calculator back up. 1168.75 divided by 2.75. So this is 425 is less than or equal to x is less than or equal to 1438.25 divided by 2.75. is 523. So they serve, I'm going to put the cafeteria serves between 425 and 523 students per day. All right, I hope that is making sense. Mark that out. Pause it if you need to keep writing. I'm going to keep moving. And actually, that's the end. All right.